Let's talk about it. Percent of students who use text messaging. You can tell this is a little bit old, so let's talk about it. Age of students. So it says if you're 12 years old, 17% of 12-year-olds text. If you're 13, 30% text. 14, 34% text. 15, 45% text. 16, 46%. And if you're 17, 54% text. I think this is a little outdated. Oh, yeah. Yeah. In fact, you'd have more like 8-year-olds, right? You know, 17 would be like a really high percentage. Well, no, you know, the big thing is babies taking selfies. Okay, I'm glad you guys are excited. Let's talk about it. 5, 4, 3, 2, 1. What would this data look like graphically? Think about it. Why? Yeah, as your age increases, the percentages go up of you being able to text, correct? So this graph would look like what, Matt?
I would put it in the line graph.
First you put your phone away and then you put it in a line graph? Okay. So it would be increasing. That's what I'm trying to get at. I think that's what you guys were saying, right? It would be increasing. Okay, what would be another way we could express this relationship? A T-chart. Good. Anybody have another one? A bar graph, but we already got graph. Graph's covered. T-chart, graph. You couldn't use a pie chart. Why couldn't you use a pie chart? Because it doesn't add up to 100%, but that's the only reason, right? Anybody else have any other ideas? We said graph and a T-chart. Guess what we're learning today? All the different ways that we could put this information, express it as a relationship. Okay, so let's do that. So I'll be able to represent relations as sets of ordered pairs, tables, mappings, and graphs. I'll be able to explain what an inverse function looks like graphically. So we're going to do that right now. No. A set of ordered pairs is like what you would graph something, like coordinates, right? Okay, so representing relations. So here's our data here, percent of students who use text messaging. So how many different ways can we express this data? Well, first we can put it in a vertical table like this. So what would be my input value? Would my input value be the student, the age of the student, or the percentage? Can you tell me why? Serena? Can you tell me why you think it's age of student?
Oh.
That's what causes a percentage. You can't have a percentage without having the number of the age of the student, right? You have to know the age of the student to know the percentage, correct? So the input is the age of the student. So if you're 12, what's the output? 17%. If you're 13, 30. If you're 14, 34. If you're 15, 45. If you're 16, 46. And if you're 17, 54. Mapping. Is this so familiar to you? It's the same thing. You put all of your input values here, 12, 13, 14, 15, 16, 17, and my output values go here. The difference between the two is if you had multiple output values, you only have to write it once, and we'll do that probably on the next one. 45, 46, 54. We call this one a one-to-one. Why do you think I call it a one-to-one? There's one output for each input, right? Okay, let's graph it. 12, 13, 14, 15, 16, 17. Let's go by 10. 10, 20, 30, 40, 50. So this would be what? Down here, how would I label this? age, and what would this be? Percent. And we're starting at 10, and we're ending with 50, and this is starting at 12 and ending at 17. It's pretty good. It's got a little bit, that's neat enough. Okay. Alrighty, so 12, I would go up to about 17, which is about right. I'm going to do a different color. And 13 would be 30, so that'd be what, 10, 20, 30, about right here. Make these dots a little bit heavier. 14 would be 34, about right here. How many of you are absolutely bored? To be honest. This is pretty easy, right? But we got to go through it, all right? It should be like your third time learning it. Okay, so 15, 12, 13, 14, 15, 45. 45's right there. Nope, doesn't get much harder. 16 is 46. Okay, so what were we on? 12, 13, 14, 15, 16? 46. So little tiny bit more, and then 54. Okay, so what happens? Does a little jump, right? Do I need to put a line between them? Not necessary. It's just data points, correct? All right, exciting stuff. Okay, so my ordered pairs are what? They're actually right here, if you want to think about it that way. So I'm going to write them. 12, 17. 13, 30. You know what my daughter does? You need to be quiet. From elementary school. Bringing it back. 14, 34. 15, 45. 1646, 1754. I'm hearing too much chatter. Okay. Finally, what are my domain values? You tell me. What are the domain values? Explain what they are. Jesse? It is. It's the 12, the 13. It's all of the input values, right? That's our domain. Our domain is all the input values. So D would be 12, 13, all the ages, right? So then what would be the range values? All the output. 17, 30, 34, 45, 46, and 54. It seems really easy here, but when you put it in real-world context, it means a little bit more. Okay, it's kind of boring when we're just talking numbers. These numbers don't mean much to us right now, right? Okay. Any questions on this? On domain, on range, on how to do your mapping? No, we're good? Okay. What if we're given values and then asked to organize it? Johnny, where would you like to start? With the table. Okay, tell me what to put in here. 2, 1, 4, -3. What goes with 2? What goes with 1? What goes with 4? And -3? -1. How can 1 go with -1 and -3 go with -1? How does that work?
Because it repeats from there's 2 arrows pointing to it.
There's 2 arrows pointing to it. They're sharing it. You know what I like to remember, how I remember this? Number 1, couldn't we make that a pepperoni pizza and make -3 a sausage pizza? And we'll say that they're $9. Couldn't a pepperoni pizza be $9 and a sausage pizza be $9? They could both be $9, right? Separately. Right? You could just have a $9 sign and then have the pepperoni pizza and the sausage pizza just arrow pointing at it, right? Couldn't you? Costco. Costco pizza is $8.99. It's really good. What do you mean?
Whoa, really?
Yeah, for a big pizza.
It's only $9.
Yes.
Costco, that's a good way to see it.
It is a way to see the family. Okay.
I'm not gonna say you want to cook.
I get a pizza and then get the chicken, the rotisserie chicken.
Oh, you put it in the crock pot? I get it.
Already made. Ask Ethan. Good. Okay. 5, 4, 3, 2, 1. Guys, I'm going to graph it. So 2, 5, 1, 2, 3, 4, 5. 1, -1 would be here. 4, 2, 1, 2, 3, 4. 2 would be there. And then -3, -1. 1, 2, 3. And see how those share -1. All right, questions? What are my ordered pairs? 2, 5. 1 and -1. 4, 2. -3, -1. And my domain values, D, semicolon, 2, 1, 4, -3. Usually we put them in order. You know what I mean? You don't have to. You do have to have the set value. The set notation right here. Least to greatest. Usually. And then range would be what? Do we need all that? It's saying the set. It's saying all these are range values. Do I really need to say something twice? Nope. So I just need 5, -1, and 2. Correct? Questions? We're good? You guys try one. Okay, so if I were to put this in a mapping, it would be 3, 2, let's put them in order this time. Be a little more organized. It should be 2, 3, 4, and -2. And what are these ones? Do -2 first? Sure. -2. Let's do like we did the last one. Let's do 2, 5, and -2. What does the 2 go with? The 5. And the 3? The 3 goes with the -2. And the 4? The 5. And the -2? The 2. Let's graph it. 1, 2, 3. -2. That goes there. 2, 5. Over 2 and up. 1, 2, 3, 4, 5. 4, 5. 1, 2, 3, 4, 5. And -2, +2. -2, +2. Ordered pairs. 3, -2. Thank you. 2, 5. 4 and 5. Outside. Go outside. Or just how about to the very back of the classroom? And -2, -2. No, -2, 2. See, Frankie, you're distracting me now. I've asked you I don't know how many times. Okay, domain values. Johnny, what will my domain values be? No, all the way back there. Johnny, what are my domain values? Let's do them in order. How about -2, then 2, then 3 and 4, and my range values? -2, 2, and 5. Good. Any questions? I just want to look at one more thing. We will. All right, think about it. Pencils down. Let's talk about this, guys. So this says average number of students per computer. So in 1992, the average number of students per computer was 18. In 94, that's when I graduated, there were 16 per student. 16 students per computer. Well, obviously one of them was me, right? 16 students per one computer. In 2002, it was 4.1 computers per student. Sorry, I keep saying it the wrong way. 4.1 students per computer.
How do you have less than one?
It's when you add them all up and divide, sometimes you get a decimal. Right. Yeah, it was a really small student.
They're like.
Okay. Guys, do you know how much it is today here at Upland High?
8, 10, 20.
2.
2 students per computer?
2 students per computer.
How many computers do you have?
In this classroom, I have 17 computers. So it would be a little less. It'd be more like 1.9, right? We got a small student in here? Okay. All right, guys, so let's think about this. Number 1, what are the least and greatest range values? This is what I was talking about, right? It looks really easy when you've got it all sorted out. Correct, Brittany? Right? When you have it all sorted out. But now I'm just looking and talking about vocabulary. So what are the range values again? What are the range values again? All the Y values, right? All the outputs. So what would be the least and the greatest range value? Not 0. No, that's a scale. That's not the actual value. What would be the highest value of an output that you get? 18 would be the highest. And what would be the lowest? 3.9. See it in there? 3.9 is actually the lowest. Okay? Describe what's happening here to me. What's going on? It's decreasing. That's exactly the word I wanted to hear. It's decreasing. The total number of students per computer is decreasing, right? Less students per computer. What would be the inverse of this? Increasing. Good. Right? If it's decreasing, the inverse of decreasing is increasing. How would you express the inverse? How could I take these values and do the inverse? Anybody know? You could switch it. I could put the students here and the year here, and the values would switch. Actually, what happens is the Y and the X switch. It's exactly how you get the inverse. And we're going to do that next. Okay? We would switch the input and the output. Alrighty. What did you learn today? How to do multiple representations, right? What does representing relations mean? Show them in an organized fashion. I really like that. On your assignment sheet, if you were to graph the following relation, describe what the inverse relation would look like. So let's graph this one, and let's describe what it would look like. So 2, 4 is 1, 2, 1, 2, 3, 4. And 4, 6 is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And 6, 8 is 2 more and 2 more, right? What's that look like? Somebody. What does it look like? Doesn't it look like a straight line that's increasing? Appears to be. What's the rise? Uh-huh. 2 up and? Not 1. Well, no. 1 what? No, you're close. I started to confuse you, I think. What's the rise? How far do you rise on the X? How far does it go from 2 to 4 to 6? How far are you rising?
Oh, 2.
And how far are you running? 4, 6, 8.
2. 1.
Which is 1. That's why I said, when you said 1, I said 1 what? Okay, so this is a slope of 1. All right, so what would be the inverse? I would switch the X and the Y, so it would be 4, 2, and what? 6, 4, and 8, 6. So my question to you is, what does that do to my graph? 1, 2, 3, 4, 1, 2. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. And this is a pretty rough sketch. And 8, 6. So what does that do to my graph? I'll give you a hint. What did you say? Well, it won't always be parallel though, but it will always. I'll show it to you this way. If you had a graph like this, this would be its inverse. Copy, paste, put a different color, do yellow. Can you see that? No. Let's make it purple. Pink. And it would do that. Uh-oh. So what do you think I just did? The inverse. What do you think the inverse is? I heard it from somebody. It's not an intersection. If I take that line and then I put it over this line, what do you think it's doing? They're opposite. Awesome. Fantastic. It's a line of reflection, guys.
It's exactly the opposite.
It's exactly the opposite, so that would make sense why it reflects, right? Isn't that cool? All right, guys, you did really good. Let me pass out your homework.